All right, let's just jump right into this explainer, because today we're unpacking something absolutely wild. We're looking at a fascinating, highly structured reinterpretation of the universe's mechanics from a body of work known as the All That's Holy, or ATH framework. So if you've ever stared up at the night sky and wondered what's actually making the universe tick, like what's really driving its expansion and where does all that light finally go? Well, buckle up. The sources we're digging into today offer a mind-bending alternative to standard cosmology.
So let's start with a massive question, one that pretty much defines modern astronomy. Why exactly does the universe look red at its absolute edges? For nearly a century, the standard go-to assumption has been that a red-shifted deep space means galaxies are literally flying away from us at terrifying speeds, stretching their light out as they run away. But what if they aren't? What if this observation, this redness, means something entirely different? Take a look at this cinematic view of Earth, surrounded by these massive, concentric red rings of light. Now, standard models will tell you this is just the fabric of space itself stretching out. But the All That's Holy sources, they propose a completely different mechanism for how light actually behaves out there in deep space. It fundamentally challenges everything we think we know about the void, suggesting that light's journey is way more interactive than we ever gave it credit for.
Okay, moving on to Section 1, the redshift paradigm shift.
To really map out how the ATH framework flips our standard understanding on its head, we just need to look at redshift. On the left side here, standard cosmology says, hey, galaxies are flying away, and that rapid motion stretches the light waves. Makes sense, right? But on the right, we have the ATH model's unique proposition, which is photon aging. The crucial point here is that ATH interprets redshift simply as light running out of energy as it gets older. It's not space stretching like some giant cosmic rubber band. It's literally just the light itself getting tired, losing mass, and slowing down over those vast distances.
Let's dig deeper into that. Section 2, photon aging in liquid space.
To really grasp why light gets so tired, we kind of have to ride along with a single photon on its microscopic cosmic journey. The ATH sources argue that space is emphatically not just a completely empty vacuum. Nope, they describe it as liquid space. It's a fabric that actually contains underlying geometry and submass. And because of this, as a photon travels, it has to physically push through this medium. It literally does work on space-time, and in doing so, it has to pay a continuous friction tax. Think about swimming through a pool of water versus just walking through an empty room. There's a geometric resistance there that slowly but inevitably drains your energy. So let's break down the mechanics of this photon aging step by step. Step 1, our photon is emitted from a source, say a super distant star. Step 2, the second it starts traveling, it immediately begins paying that friction tax to the liquid space around it. Step 3, because of this constant toll, the photon actually loses its speed and its internal curvature mass. Its energy is exponentially decaying over distance. And finally, step 4, it reaches a point of total exhaustion and just dissolves entirely into the geometry of space. The absolute key takeaway here is this beautifully simple equation. Older light equals slower light, which fundamentally results in a longer wavelength. And in the world of physics, a longer wavelength is exactly what we call redshift. So you see, the ATH framework accounts perfectly for the red night sky, but without needing the entire universe to be flying apart. It's simply the visual signature of tired, aging light paying its toll to the cosmos.
Which brings us to Section 3, hitting the light wall.
We followed our aging photon across literally billions of light years. But what actually happens at the very end of its journey? Where does all that taxed energy go? Well, the sources phrase this beautifully. They state, the photon dissolves into the space-time energy reservoir it helped create. In the ATH model, light doesn't just travel forever into some infinite, uncaring void. Eventually, it runs completely out of gas and hits a transition gate known as the light wall. At this boundary, the photon's ability to interact as a moving particle of light just vanishes. But, and this is key, its energy isn't destroyed, it's repurposed. When we map out the ATH curvature engine here, we can actually see what happens when those exhausted photons hit the light wall. Their energy is deposited directly into the fabric of the cosmos. They dissolve to build and reinforce the geometric memory of space itself. So that light that traveled for billions of years, it literally becomes the structural architecture of the universe. How cool is that? Moving right along, Section 4, the 13-layer infinity sphere. Now, zooming out from the microscopic life of that single dissolving photon up to the grand macro architecture, The ATH framework structures the entire universe as this highly organized 13-layer scale ladder. Notice on the right side of this diagram how the structure extends upward to massive macrocosmic clusters, like galaxies and superclusters, and then extends downward to the microscopic sub-Planck floor, like atoms and quantum fields. It's a unified, perfectly closed system operating under the exact same physics across all of these magnificent scales.
Let's actually break down those specific layers, because the math here is fascinating. You have 7 positive layers going upward into the cosmic scale, and 7 negative layers going downward into the microscopic scale. But they meet perfectly at one balance node right in the center, the 0 point. And because that center node is shared by both directions, it creates exactly 13 total layers. But these layers don't just stack like pancakes. They fold back on themselves into a closed toroidal shape. The sources describe it as an infinity sign sphere. Basically, a living, breathing, 13-layer membrane that completely surrounds us.
Next up, Section 5, the antimatter drip. So if this 13-layer infinity sphere operates like a living, breathing organism, what sets its pace? Well, the ATH model completely redefines what we call the antimatter drip. It describes it as a rhythmic, linear release of particles from neutron stars. It acts as a literal mechanical pressure valve for curvature compression. The sources are absolutely clear on this. Antimatter isn't just some random leftover accident from the Big Bang. No way. It is a highly calculated exhaust emitted precisely one particle at a time to keep the universe's outward expansion, its cosmic exhale, perfectly stable.
But you have to ask what happens when that exhaust mechanism finally finishes its cycle. That brings us to this incredibly important number right here, 0. 0 is the exact threshold point when the antimatter drip eventually depletes in a given cosmic region. The pressure valve fully closes. Mapping out that sequence shows us exactly how this all connects. We are currently right now in the outward breath phase, which standard physics just refers to as dark energy or cosmic expansion. During this time, antimatter drips steadily, releasing pressure. But once that drip hits 0, it triggers the ultimate cosmic flip. The breath reverses. The universe shifts from a massive outward exhalation to an inward inhalation, a contraction phase. It's just a continuous self-regulating cycle of a genuinely living cosmos.
Which brings us to our final slide, and a pretty provocative question I want to leave you with today. After unpacking this explainer, when you look up at the night sky tonight, do you see an empty, aggressively expanding void? Or do you see a living, breathing 13-layer organism, built and sustained by the exhaustion of light itself? The All That's Holy framework certainly gives us a fascinating, highly structured new lens to view reality through. Thank you so much for joining me for this explainer. Keep asking those great questions, and I'll see you on the next one.